All right, so for example number 1, we're asked to solve the system of linear equations by substitution. So here we have essentially, why is that doing it that way? We have a system of linear equations. So we have this equation, and then we have this equation, and we're going to solve it by substitution. So what they're going to do is they're going to solve this equation for x by basically they just added y to both sides. And when they did that, they got x equals y minus 2. And then they take the other equation, which was originally x plus 4 or plus y equals 4, and wherever there was an x, they substituted in. Actually, it was negative x, sorry. Wherever there was an x, they substituted in y minus 2, solved, and they got 2 is equal to 4. Well, that's false. 2 will never equal 4. It can't. So whenever you get a false statement, that means there's no solution. Well, the reason there's no solution is when you graph them, what do you notice? They're parallel. They're parallel lines. And so since when you graph both equations, the graphs do not intersect, so there is no solution. Does that make sense? Which is kind of what we said before. And then now for part B, it says solve this system of linear equations by elimination. Well, I want to point one thing out. If I take, and I know that this is infinitely many solutions, because if I take that first equation, 2x plus y equals negative 2, and I take that whole equation and I multiply it by 2, what's 2 times 2x? 4x. What's 2 times positive 1y? 2y. And then what's 2 times negative 2? Negative 4. Isn't that the second equation? Yeah, so what does that tell you about those lines? They're the same. They're the same. So when I graph them, they're going to be the same. But anyways, they want us to do substitution. So it says, take the first one, multiply it by 2. So this is what I just did. And you'll see that they're the same line. When I multiply it by 2 and then I add them up, I get 0 plus 0 equals 0, or 0 equals 0. Now, the infinitely many solutions will be true. You'll get, and it'll be a number. It won't be x equals 4 and y equals 2 or anything like that. It'll be like 0 equals 0 or 3 equals 3. But whatever that is, you'll get the left-hand side equaling the right-hand side. And as long as that statement's true, 4 equals 4, 7 equals 7, 10 equals 10, then you have infinitely many solutions. So the graph, I think you guys understand, but now they want you to understand how do you do this with algebra. Does that make sense? All right. Any questions before we move on? Does that make sense to you guys? All right. So now let's reflect on this. It says if x represents a variable and A and B represent constants, A cannot equal B. Interpret what each result means when solving a system of equations. Well, we said when x equals A, that means, what do you think that means, you guys? When x equals a number, what does that mean? Very good. Yeah, there's one solution because you're saying x equals a number, and that works. Now, when we have A equals B, but A doesn't equal B, yeah, it's no solution. Very good. And when you get A equals A or B equals B, it doesn't matter. I'm going to put that down here too. B equals B. What do you get? Infinitely many. Very good. Either you kids are really smart or you have an amazing math teacher.
Or we just guessed really well.
Last year you did? Oh, nice. Infinitely many solutions. All right, so now for part B, it says, in part B, can you tell without solving that a system has infinitely many solutions? If so, how? Yes. I'm going to use some fancy math words, but so you could say one equation is a scalar, scalar like scale but with an R, multiplier of the other. I'll explain what that means. So what did we do for that infinitely many solutions? We took the first equation, multiplied everything by a number, and we got a different equation, but when you graphed it, it's the same. That number that we multiplied was what we call a scalar multiplier. I multiplied by 2. In other words, if I took this whole equation and multiply it by 2, 2 is what we call the scalar multiplier. I'm multiplying it by 2 to get the second equation. So if you look at both equations and you go, man, that equation looks like the first equation multiplied by 3. Or you look at it and you go, man, that first equation looks like the second equation multiplied by 4. And you do the math, and that's the case, then you have scalar multipliers, which means they're the same exact graph, okay? Or you could just graph them both. So now let's look at this one. This is solve each system and see if they're true. But now I'm going to do something here. I'm going to skip immediately to this one. If I multiply this by -4, what's -4 times 1? -4. What's -4 times 2y? -8y. What's -4 times -3x? +12x. How many solutions does that one have? Infinitely many. So this is infinitely many because one equation is a scalar multiplier of the other. In other words, I'm multiplying the first or the second equation by -4 to get the first one. Now the other thing that no solution occurs when they have basically the same slope. How do you want to solve this one? Do you want to do substitution or do you just want to add them up? Let's just add them up. So I'm going to take the second equation. If I multiply this by 2, I'm going to get -4x plus 6y equals +8. And then I've got to add that to the first equation, which is 4x minus 6y equals 9. So this gives me this equation. And then I just took this one and wrote it here. When I add them up, the 4's cancel, so I get 0x. These cancel, so I get 0y. And then when I add these up, I get 17. So if you add it all up, I get 0 equals 17. Yeah, that's false. And so false means that it has no solutions, right? And then we'll do this one in red. Same thing here. If I'm going to multiply this first equation by a -2 to cancel the x's. And so I get -2x. -2 times +2y is a -4y. -2 times 6 equals -12. We'll zoom in a little bit. So when I add this equation with this one, 2x minus 2x is 0. This becomes -7y is equal to 14. Divide both sides by -7. I get y equals 2. If I take that first equation, x plus 2 times y, but we believe y is equal to 2, then you're correct, it'd be negative 2. Then I get x minus 4 equals 6. Add 4 to both sides. I get x equals 10. In other words, this has a solution of 10, comma, negative 2. So we got one solution. Does that make sense? Pretty good. All right, I'm going to leave this up on the screen so you guys can finish writing it down. That last one, I'll zoom out a little bit. It's almost time to go.